This video is on general relativity. The second of Einstein's two theories of relativity is based on my book Pondering Relativity, an illustrated guide for building an understanding of Einstein's relativity. My name is Doug Funke. I'm a certified professional ergonomist, and my book uses human learning principles to make relativity understandable. General relativity expands on Einstein's earlier and first theory of relativity, now known as special relativity. It does three things. It explains accelerations in addition to simple relative motion in time. It defines how gravity works, and it more fully integrates time with space. If you remember my first video on special relativity, you'll realize that special relativity is based on two principles. One, all motion is relative, and two, the speed of light is constant. And when you combine these two principles, you realize that time on moving platforms must run more slowly to account for the shorter distance or the shorter pathway that light takes on those moving platforms, sometimes referred to as compressed space. Moving clocks run slow to account for the fact that time on moving platforms runs slow. But Einstein was not satisfied with this explanation. He spent 10 years expanding it to his more complete theory called general relativity. And this is what he had a problem with. He had a problem with this. With if you look at this situation with just general special relativity, in this situation, the spinning bucket could be spinning in the universe, or because of motion being relative, the universe could be spinning around the bucket. But if it were the universe spinning around the bucket, then how to account for the accelerations felt on the spinning bucket? This is what Einstein was able to define with his general theory of relativity. Einstein also noticed that there seemed to be an interaction between accelerations and gravity. Here in this another, again with the example of a spinning bucket, the faster the bucket spins, the more water spills out, and the more horizontally the water seems to spill out. There seems to be an interaction with the acceleration forces and with Earth's gravity, with accelerations basically fighting against Earth's gravity. And he also noticed that the sensation of acceleration and the sensation of gravity on Earth's surface are really equivalent. They're the same. You can't tell them apart. And he also noticed that both of them are related to the body's mass. The more massive a rocket ship is, the harder it is to accelerate that rocket ship, the more energy it takes to accelerate that rocket ship. Similarly, the more massive a planet is, the more gravity is created. He called this his equivalence principle. And he actually went a step further, and he actually showed us how you can combine acceleration with gravity in this famous picture of him riding his bike in a curved direction. He defined, based on all of this, two types of frames of reference. The accelerating frames of reference, like we just discussed, where you feel a sensation of acceleration, and inertial frames of reference when you are away from any sources of gravity or in free fall. And those are inertial frames of reference. And he determined that the reason for all of this is that time and space are not separate things. Time is really the fourth dimension, adding to the three dimensions of space that we're familiar with. And if you were not to appreciate this, which we normally don't, when the moon orbits around the Earth, as in the upper figure, it would appear that there must be some force pulling the moon towards the Earth. But if we could appreciate the fourth dimension of space-time, that the moon is really just following the natural contours of space-time as bent by Earth's gravity. This is how gravity works. And Einstein related this to the inertial and accelerating frames of reference we just discussed. And accelerating frames of reference are really are created by violating or pushing against or through the natural contours of space-time. For example, an accelerating rocket ship, or on Earth's surface where the natural contours of space-time would naturally pull you to the center of the Earth, but Earth's surface is preventing you from following those natural contours. In contrast to inertial frames of reference, where you are away from any significant sources of gravity or in free fall, in both cases following the natural contours of space-time. And he also determined that accelerating frames of reference are also associated with slowed time. And the greater the acceleration forces felt, or the greater the gravitational field, the more slowing of time you experience compared to in inertial frames of reference where there is no slowing of time created. And he helped us relate this to special relativity. If you look at this example that Einstein asked us to imagine, it being at the center of a spinning disk, without feeling any acceleration, time is not slowed, but when you look at the outer edge of the spinning disk, which is moving across your field of view at a rapid rate, just from the general, the special relativity effects of relative motion, you have slowed time. But in this example, you can see how that's really related also to accelerations. It was his way of helping us see how special relativity and general relativity can be related and are really based on the same phenomenon. And the notion that space and time are really not separate things really makes sense. You can't define a location on Earth without specifying your time for being there. In this example, moving through space-time, again, moving through the Earth's surface, you're moving through both space and through time. The time dimension being shown on the axis here. And as you move along the Earth's surface, you're moving through both space and time until you get to a red light, and then you stop moving through the spatial dimensions, and you're only moving through time until the light turns green, and then you're moving through space and time again. And really, this makes a lot of sense when you relate it to our experience on Earth. And this beautiful picture of the Niagara River is beautiful and has just a very, very good picture of space. But until you add the time dimension, it doesn't have any essence. It doesn't have any meaning. It doesn't have any deep relevance beyond just being a pretty picture. But when you add the time dimension, it comes alive. You have essence. You have deep meaning. Time adds meaning to the universe. So to summarize, general relativity again expands on Einstein's earlier theory of special relativity. It explains accelerations in addition to just simple relative motions in time. And movement relative to space-time is what defines acceleration and how acceleration works. It what distinguishes between inertial and accelerating frames of reference. And also an object's mass is what determines the amount of acceleration that's achievable. General relativity also explains how gravity works. And Einstein pointed out that gravity and accelerations are really equivalent and really the same basic phenomenon. And gravity works by bending space-time. Planets and large massive objects create gravity by bending space-time. And again, very much like accelerations, it's the object's mass that determines the amount of gravity that's generated, the amount of bending of space-time that's experienced. So in both cases of acceleration and in gravity, it's the object's mass that relates to the amount of acceleration felt, the amount of gravity created. And in the Again, that was what Einstein called his equivalence principle. And most importantly, time and space are more fully integrated in his more complete general theory of relativity. And it is time that adds essence to space. It's time that gives meaning to space. It's time that gives meaning to life and gives meaning to the universe. Again, thank you for listening to my video on general relativity. It's based on my book, Pondering Relativity, an illustrated guide for building understanding of Einstein's relativity. You can get it at Amazon.com, or you can visit my website, ponderingrelativity.com. Thank you.